and welcome to my presentation. I hope you are all doing great, those who are here in Wrocław and those who are watching us online from all over the world. For those who don't know me already, my name is Michał Chudziak, and I'm an independent consultant on React Native. You can find me on GitHub, Twitter, and LinkedIn under the following handle. And if you'd like to know me better, I invite you to visit my website or simply talk to me after the presentation. Before I begin, I'd like to thank the organizers for inviting me here today. I spent over 6 years working at Callstack in the development and leadership roles, and I have to admit that it is one of the best places in the world to grow as a software engineer. So if you are looking for opportunities to grow, I recommend you joining their team. As you can see on the screen, our topic today is answering the question, how to actually improve the performance of a React Native app. And my talk is particularly relevant to those who want their app to perform well on every platform, those who have tried to improve the performance with little or no success, and those who had managed to improve it only to have the issues suddenly come back. Ultimately, it's for everyone who wants to deliver the best possible user experience to the users of their application. Okay, so let's start. Suppose your average application rating diminished by half a star only over 3 months due to an increasing number of performance issues. This caused a 0.5% cutback in the user base and significant revenue shrinkage. So, have you ever wondered how would you respond? I will come back with the solution soon, but before I do that, let me quote a few facts. Nobody likes slow apps. Statistics show that increasing customer retention rate, even by just a margin of 5%, has the potential to increase the profits by 95%. And what's more, most companies agree that retention is cheaper to execute than acquisition, and the customer's perception of their brand is directly affected by their initial impressions when engaging with it. Ultimately, losing a customer due to the poor application performance or stability is preventable and should never happen. Here are some interesting quotes from industry leaders to back up this thesis. It doesn't matter what market or industry you operate in, because performance is critical for everyone in 2022. Companies compete for our attention and screen time, and more devices are adopting refresh rates well above 60 Hz. Everyone wants smooth and quick interactions. The content has to be there, fast. You have to deliver, or you're out. Okay, so now that we know that performance is important and that it's not so good in our app, it's time to roll up our sleeves and get to work. So have you ever been in such a situation? Back in the day, I was, and I wasn't sure what the reason was or how to fix the issue, so I did what every developer does in such a moment. I Googled it. And in my Google search, I ran into many tips and techniques that I could apply to my code base. Different articles and YouTube videos told me to use scrolling lists, use only high-performance components, use native driver, use memoization, try using a different navigation library, remove console logs, use external libraries, don't use external libraries. And there was so much information, sometimes contradicting itself, that I couldn't decide what to do or where to start. So I followed my intuition, guessed the problem's origin, implemented the techniques in question, and failed miserably. So the improvements were slight, almost unnoticeable, and the user experience was still suffering. And it's not just me. Recent research indicates that even though the majority of organizations have improved their ability to collect the performance data, many of them are also unable to identify and resolve these issues in a timely manner. So after a rocky start and some back and forth, and with my help of my colleagues that are here with me today, I managed to optimize the app. But the process was painful and took way longer than initially expected, as I played hide and seek with the bugs. So what did I do wrong? As the time flew by, my team and I approached several other similar projects. And our approach became more structured over time, and we were able to deliver better results more quickly. So my experiences led me to several conclusions. First of all, while working on such projects, you have to avoid guesswork as much as possible. Poor assumptions can lead you to false results. So always base your decision on data. Otherwise, you're wasting your time. Usually, performance issues are like a resultant force. So several factors impact your application, and there's no secret sauce, no magic elixir that can fix it all at once. Sometimes one simple change improves performance by a lot, but usually there are several factors that needs to be optimized, which we've just seen, and it takes time to improve, and it should be a continuous process. Finally, I've seen several teams, usually working on a large projects with high fluctuation that needed help with performance periodically. And these days, there's ever-increasing complexity of business requirements, platforms, paradigms, etc. And the first rule of optimization says, do less. And it's really hard when you have to do more. Ultimately, the user interaction with the app is a process. And the code that drives the user through this experience serves as a foundation of this process. So we have input, some interaction options, and the code that backs it all up. And we expect a final result. This process could be optimized, like any other. UI and UX experts are doing it from a layout perspective, but we can also improve it from a purely technical side. And you know what? It turns out that humans are good at optimizing processes and have developed many techniques and methodologies around that. Some of them are decades old, well-tested, and continuously improved. So during my time as a manager, I learned some of those and participated in several optimization projects. So I found a lot of similarities between their stages and the technical improvement projects. And combining the knowledge I acquired while working on Lean Six Sigma projects, and by the way, Lean Six Sigma is the state-of-the-art methodology for improving processes and work efficiency, with my previous experience with the optimization of the React and React Native apps, helped me to improve the structure and overall efficiency of my work and performance optimization efforts. So let me present you with the methodology that's commonly used for process improvement or solving business cases, and is very data-driven and well-structured, but what's best about it is that it can be well applied to the optimization of React Native apps. It's called DMAC, and this acronym stands for the first letter of each phase. So let me walk you through each phase and show you how I usually apply it to React Native. The first step in our process is a define phase. So this is the moment where we should focus on defining the problem, project goals, opportunities for improvement, and customer deliverables. In short, we need to define where we want to go. It's like when we are planning a vacation. We scour through different destinations and choose the one that suits us best. So we start by listening to the voice of the customer. The voice of the customer is a term that describes your customer's feedback about their experiences and expectations for your app. And by listening to the voice of customer, we can better understand what the needs of our customers are, what their expectations and preferences are, and what problems they are facing. We can listen to it by building a voice of customer program, implementing feedback forms within the app, or evaluating users' ratings and comments on the app stores. But voice of the customer is often vague and hard to measure. So we need to translate it into something more specific and easily measurable. And the measurable elements of a product or service that clearly show the customer satisfaction levels are called critical to quality, or CTQs. So as you can see on the example, we take one of the VOCs, which is usually constructed from the clustered feedback, and we break it down into measurable components. So in our case, customers want a fast checkout. So after analyzing cluster components, we know that this means a swift checkout process, short wait time on checkout flow, and smooth interactions and transitions between the screens. And this is further decomposed into CTQs that are measurable and easily trackable. Another handy tool is user path analysis. It's good to know what our users do in our app in order to know what's most important to them. And with good tracking, we can analyze path funnel data, which shows what areas of the app were visited, in what order, or trace the paths on the individuals who end up uninstalling the app. Earlier, I mentioned that not everything can be fixed at once. And this fact is very important to remember, because there's usually a lot of pressure from a business that we have to deal with. And at this point, you should choose what's most important and the order in which you will optimize things. So don't spread too thin, be laser focused, and tools like prioritization matrices can help you choose. Ultimately, we need to define where we want to go, and this means we need to know what we want to improve and what the expected results are. So outline the metrics that will be measured and what the final targets are, and it's a good practice to put these goals along with the project scope, direction, and motivation into a project charter, as it gives a good overview and on the project and facilitates the communication with the business. Now that we know where we want to go, it's time to assess the starting point. So the route to the beach is different when you are in a 5-star hotel with an ocean view and when you are in the middle of the swamps. It's time to assess the extent of the issue and quantify it with the data. The measure phase is all about collecting as much data as possible in order to get the actual picture of the problem. This means we need to ensure that the measurement process is accurate and precise. And even though I said we need to gather as much data as possible, you should be efficient in your data collection, as the complexity in software engineering is high and you can easily get overwhelmed. So it's really helpful to prepare a data collection plan and metrics, and at this point you can describe the data, select and validate the collection methods, assign team members, and prepare a data repository. And after we're done with that, we move to profiling. React Native is a framework that lets us build user interfaces using JavaScript and render native UI components under the hood. So this raises a question of whether to profile JavaScript or the native side. And there's no clear answer to this question, as it heavily depends on your tech stack and architecture. Usually, it's a mixture of both. However, the majority of performance issues in React Native come from the JavaScript side. One of the most useful tools is React Profiler. It's a built-in API that helps us measure the number of renders and the amount of time necessary to render a component. It's very handy, as the performance issues often come from unnecessary rendering. And it's mostly designed to work in the development mode, but you can use a special version of React to measure in production builds. The second tool, a library called React Native Performance, is one of the most useful profiling tools for JavaScript in React Native. And it's an implementation of the performance API from the web APIs for React Native. And it lets you place native markers in the code and measure the execution time. It also allows you to verify the network requests and export several useful native markers. Most of its functionalities work both in development and production. And by the way, there's a Flipper plugin that you can use to visualize the output. On the native side, the most common way is to use profilers built into native IDEs. Within Xcode instruments and Android Profiler, there are many tools to monitor resource consumption and network traffic, as well as process trace across the threads. You can gain a lot of useful insights by analyzing the results. So I strongly recommend spending some time learning how to use these tools, or watching the presentation that were presented before me. And another technique that's simple and straightforward is using stopwatch, but don't do it. It's better to use screen capture and analyze the video frames. It's way more precise, as we don't rely on our reflexes. And trust me, they are really bad in my case. Another tool, or more accurately set of tools, is Flipper. Flipper comes with several plugins that can help us measure the different KPIs in the development. And you can use the Perf Monitor plugin for a Lighthouse-like experience, List Profiler plugin from Shopify, or a plugin that supports the React Native Performance library, which I've just mentioned. There are several aspects to consider while doing measurements, and the most important is measurement variation. So due to different environments that we can wrap our app in, we have to be very careful and precise while profiling, and we should consider different platforms, different operating systems, different phones, etc. And even if it is run on the same device, there might be external factors that impact its processing capabilities. And to ensure result certainty, you should base your measurement on the release builds and account measurement variation. As I mentioned before, our measurements should be accurate and precise, and ensuring both will reduce the measurement variation. So even though these two terms seem similar, they touch on two different aspects of measurement. Accuracy is the tendency of measurement to center around a given value, while precision describes the ability to achieve the same results under the unchanged conditions. So I encourage you to read more about accuracy and precision, as each has a set of factors that impacts it, such as bias, linearity, or stability for accuracy, and repeatability and reproducibility for precision. Decomposing measurements to these factors can help you do a measurement system analysis, but of course it's not something you need to do in every case, but it helps if you want to be absolutely sure. Now that we have all the data, it's time to start the analyze phase. So you can think of this phase as defining a route from point A, which is our baseline, to point B, our target. And the goal of this phase is find the root cause or multiple root causes of our problem. It's good to start by creating a long list of potential issues. So gather your team and outline every factor that could have an impact on certain KPI. There are several brainstorming tools that you might use to help yourself structure the work and discussion and facilitate gathering ideas. I will show you my favorite one in a second, but I just wanted to mention that even if you are working alone, these tools are helpful to organize your thoughts. The tool I just mentioned is called cause and effect diagram, and it's also known as a Fishbone Diagram, and just guess where it gets its name from. Yeah, you're right, it's a fish. Anyway, the Fishbone Diagram is typically drawn from right to left, with each bone of the fish branching out to include the data containing more detail. We start by drawing a head. The head should contain a problem statement. So we've already defined several problems in our app and confirmed them during the measurement phase. So I'm going to put a low FPS number on the product catalog screen as our brainstorming subject. Then we identify potential major causes that could contribute to our problem. And in our case, it could be poor measurement, issues with the thread bandwidth, or rendering the list, or bad application architecture. So if you come up with more groups of potential causes, that's great. We can simply extend the body of the fish. And after we're done identifying groups, we outline potential causes. There are many things that could have an impact on poor performance in certain areas. And at this point, we need to create a long list, so put down everything you can think of. Now, as the Fishbone diagram shows all of the many possible causes of the problem, we need to narrow the list. So analyze the diagram and choose which causes aren't likely to have an impact on the issue and those which needs further investigation. Outline the factors that you find most relevant, and it will be a bit arbitrary at this point, but don't worry, we'll go ahead and test them anyway. And keep in mind that there might be several factors and root causes for performance issues. As I mentioned before, it's like a resultant force. Finally, once we have defined our hypothesis, for example, prop drilling causes performance issues on product catalog, it's time to find out the truth. So there are a lot of guides on how to perform hypothesis testing by the book using statistical data, but in our case, it's not often needed. What's important is the testing process. So we start by defining a hypothesis, which we've just covered. Then we need to design a test that will help us accept or reject the hypothesis. And it will be probably some proof of concept to compare the impact of a given factor on a final result. Subsequently, we interpret the results and outcomes of such tests and decide whether it has improved or not. Then we make the final decision. Finally, it's time to hit the road. So now that we know where we are, where we want to go, and how to get there, it's time to get our hands dirty. So this is the moment when the optimization technique starts to make sense. You're not the confused sneak anymore. You know precisely what's the root cause of the problem, and you can fix it. But every problem can be fixed in several ways. So before starting an actual implementation, it's good to have another brainstorming session with other engineers And you can either do it offline with some pizza and sticky notes or online using various visualization tools. There's a variety of solutions depending on your root cause. Many of them are well described, and I have outlined several generic things that you can consider when looking for a solution to your problem. In my experience, problems are usually related to the poor React usage and frequent reconciliation of the layout, and that's not always the case, but it's often that. And after you're done outlining solutions, evaluate their pros and cons and select the one that suits you best. Remember that sometimes the solution that brings the best results might be extremely costly. For example, when you have to do a major architectural changes in your code base. Sometimes you will have to make compromises, and you will have to accept that. Finally, as you and your team have reached a consensus on what to do, just do it. It becomes so simple at this point. So after finishing the implementation, make sure to do appropriate testing, and if results are great, well done. Your app isn't bad anymore. The last step, but certainly not the least important, is the control phase. So we fixed our app, we've started receiving positive comments and ratings, and management is happy with our work. So life's good, but will it stay like that? How can we be sure that it is permanently fixed? This is what the control phase is all about. Not only we need to validate the improvement, but we need to also ensure that it will stay with us. And if we take a look at the performance of the apps over time, we can observe a cycle where refactors and optimizations intertwine with feature development. And as I mentioned before, there's a high level of complexity that we deal with while developing the apps, which is an opposing force to our optimization efforts. So usually, if you do nothing to keep the app performing right, you will experience issues at some point. The performance will degrade if not under control, and there's nothing wrong with that. People tend to look for something to blame once they start experiencing issues. They blame the framework, devices, users, or others. And well, you shouldn't do that. You just have to accept this fact and prepare for it. So, what do we need to do in order for our chart not to look like that, but rather like that? Can we do something to keep the app performing right, the performance under control, and continuously improve it, rather than launch a big optimization project every year? And the answer is yes, we can, and the control is the key. A control plan is simply a strategy to ensure quality. So we can use some of the work from previous phases to define the areas we want to control. We should outline focal points, scenarios, measurement characteristics, acceptable ranges for each indicator, and testing frequency. Additionally, it's good to define some procedures on what to do if we spot the issues. The most crucial aspect of controlling is closely monitoring the regressions. Some time ago, we haven't had many options to do it easily with React Native. Fortunately, thanks to the amazing work of folks from Callstack, Google, and Sentry, that has changed. The first library that I wanted to recommend is Reassure, a great tool to monitor app performance regression on CI or a local machine. You can read about it more on Callstack's GitHub. Then we have the Firebase performance monitoring from Google that allows you to gain insight into the key performance characteristics within your released app. Finally, there's Sentry performance monitoring, which tracks application performance, measures metrics, and displays impact of errors across multiple services. Performance control has never been easier. That covers just about everything I wanted to say about the process, so I hope this information should help you structure the work and achieve satisfactory results. However, if you ever need some help with performance optimization or anything else related to React and React Native development, feel free to reach out to me via my website or any other channel. I would be happy to help. Thank you.